related rates problem together. We have a baseball diamond in the shape of a square where each side is 90 feet. So that means this side is also 90 feet, that's 90, and that's 90. A batter hits the ball and runs towards first base with a speed of 24 feet per second. So where he is at any given time is some distance away from home base. And we know that distance is changing. So dx dt is changing at a rate of 24 feet per second. So it's getting bigger, right? As he gets closer to first base, the distance away from home is increasing. So that's a positive rate of change, 24 feet per second. In part A, we are looking for what is his rate, at what rate is his distance from second base decreasing? So this is going to be his distance away from second base. So if that's y, you're looking for dy dt, which should be negative if it's decreasing, when, and it's a moment in time, he is halfway to first base. So when x is 45. All right, so now we need a relationship between x and y. And we see here, if we continue on this line and this line, we easily see we have a right triangle here. Let's come over here and draw it. Where this distance is not x. So if this whole distance is 90 and this little piece is x, then that piece of the triangle is 90 minus x. So 90 minus x, 90 on this one, and y is here. So using the Pythagorean theorem, we can come up with an equation that relates x and y. So we get 90 minus x squared plus 90 squared is equal to y squared. As is always with related rates, if we have our equation with the two variables, we now take the derivative of both sides with respect to time. Right, so d dt of both sides. And we end up with 2 times 90 minus x times negative 1 dx dt plus the derivative of a constant is just 0 equals 2y dy dt. All right, so remember, we are looking for dy dt at a particular moment in time. So we need to solve for this value. We see if we divide both sides by 2y, that's going to give us dy dt. Now let's plug in everything that we need. Notice first that those 2's cancel nicely. I know that x is 45, so 90 minus x is 45. We have a negative, and we have dx dt, but notice we also have y here, and we need to know what y is. So again, it's at this moment of time when x is 45. So at that moment in time, 90 minus 45, I actually have this triangle. So what is the y during that moment in time? Well, I see again, y squared is 45 squared plus 90 squared. So y is the square root of 45 squared plus 90 squared. Okay, so now I have everything to plug in to solve for dy dt. So negative 45 over the square root of 45 squared plus 90 squared. Dx dt that was given in the problem was 24. And this was feet per second is your dy dt. And using a calculator, you can see that this is approximately negative 10.3 feet per second. So it's negative because that distance is decreasing. Oops, sorry, I should say negative. This distance is decreasing as he moves towards first base. See? That's a slightly shorter one. Okay, now let's look at part B. Part B is, at what rate is his distance from third base increasing? So this is right there. We'll say that's Z. And as he moves along this first base line, that X gets bigger, and so does the green line, the Z. So we see we have a nice triangle here. So let's put B here. So B, we want to find out what dz dt is at the same moment in time. So when x is 45. So let's look at the triangle we get this time. We now have z x and 90. Instead of 90 minus x, we have x. That's our right triangle here. So we do the same thing. We create our equation. X squared plus 90 squared is equal to z squared. We take the derivative of both sides with respect to t. We get 2x dx dt plus 0 equals 2z dz dt. And again, we solve for dz dt by dividing both sides. Notice those 2's cancel. So we have x over z dx dt is equal to dz dt. Again, we know what dx dt is and we know what x is. We have to use our triangle to figure out what z is for our moment in time. So again, we have 45 squared plus 90 squared is equal to z squared. So we have 45 over the square root of 45 squared plus 90 squared times 24. And that's also 10.3, but this time positive. And that is what our dz dt, approximately dz dt. So y is decreasing at a rate of 10.3 feet per second, and z is increasing at the same rate. Cool.